Hi future doctors, welcome to the next class. In this class, we will discuss moving charges, and magnetism. So moving charges and magnetism. In this, first we will discuss force on charge in magnetic field. How the magnetic field is going to be represented in this lesson. So if they have given in 2 marks like this is going to be magnetic field inside into the board. If they have given dots like this, so this is also magnetic field, but it is going to be outside the board like this. Next, if you want to write in terms of direction, so k cap, that is into means minus k cap. This b bar is into board means minus k cap. Outside means this is nothing but plus k cap. So this is also magnetic field, uniform magnetic field. So but this is along plus I cap. So this is uniform magnetic field. This is minus I cap. So this is also uniform magnetic field. This is going to be plus j cap. So this is magnetic field means this is going to be minus j cap. So among all these, if charge is going to be entering with some velocity, then how the force is going to be acting. So for that, what we will get the formula means F bar is equal to Q into V bar cross B bar. So this is the force formula on the charge if it is moving with velocity V in uniform magnetic field. What is the force acting on charge in electric field? If you have taken electric field like this, electric field direction is always from positive to negative. If you leave one positive charge at rest position, then it will be moving in the direction of electric field. How much force is going to act? F equal to QE. If you use one negative charge, it will be moving in the opposite direction of electric field. So F bar is equal to QE bar, this force along plus I cap. So this force is along minus I cap because it is coming opposite to the electric field, left side. Same like that, how much force is going to act on the charge in uniform magnetic field means this is the equation. So by using this, how force is going to act, we will see one by one. So if we are taking so charge at rest position in this, the charge is going to be placed in this magnetic field. Its velocity is 0 if it is at rest position. Then how much is the force? Force is also going to be 0. So among all these, wherever you are taking, if velocity of the charge is 0, it will be at rest position only because force is going to be 0. Next, magnetic field is into the board. So charge is also entering into the board. Charge is also entering into the board means V minus K cap in the direction of board. Then what is the force acting on that? What is the force acting on that means F bar is equal to QVB sin theta n cap. So velocity is there, charge is there, magnetic field is also there. But what is the angle? Angle between V and B. So minus K cap, minus K cap. Therefore angle is 0, sin 0 is 0. Therefore force is 0. Then force is 0 means according to Newton's law. So unless and until external force acting on it, it will be continuing in its path. Therefore it will be moving in a straight line path. So let us assume velocity, charge is coming outside of the board. So outside of the board means velocity is in the direction k cap. So at that time, what is sin 180? So QVB sin 180. Sin 180 is also 0. Again, in that case also, force is going to be 0. So you got two things. If charge is entering with some velocity in the direction of magnetic field, force is going to be 0. If charge is entering in the opposite direction of magnetic field, velocity with some velocity opposite direction, in that case also force is going to be 0. Now what is the path followed by this charge? They will ask. What is the path followed by the charge means it is going to be straight line. Straight line means In which direction it is going? It will continue its direction because external force is going to be 0. Next up, a neutron is entering the vehicle. A neutron is entering means, what is the neutron charge here? Neutron charge is 0. Therefore, force is going to be 0. Isn't it? There is no force on neutron due to magnetic field. So, among all these cases, when force is going to be 0, we are discussing. Isn't it? So, if velocity and magnetic field both are in same direction, force is 0. Velocity and magnetic field both are opposite direction, force will be 0. If neutron is entering, so neutron chargeless, therefore force is going to be 0. Now, if force is acting, let us assume, then in which direction that force is going to be acting, we will see, and how to get the directions also, we will see. See here, magnetic field will be into the board I am taking. So, whenever magnetic field is into the board, now charge is going to be entering with some velocity v right side. So, same they may give charge is going to be entering either positive charge or negative charge. A positive charge is going to be entering with some velocity v. Now, what is the force direction in these two cases? We will see. In any direction they may give. First time seeing, we are discussing these two cases. So, for this our main formula is going to be this one. F bar is equal to Q into V bar cross B bar. So, whenever you are taking that formula, now you require directions. So, charge is positive, therefore plus. I am drawing only directions here, plus Q. Now, what is the velocity direction here? Right side means I cap. Now, what is the magnetic field direction here? Magnetic field is into the board, minus K cap. So, then right hand palm rule, thumb rule, among all this is the best method you can get the direction of force. Now, in which direction force is going to act? So, now what is I cap cross K cap? So, we came to know, again this one we discussed in basics. I cap, J cap, K cap. So, if you are taking I cap cross J cap, I cap cross J cap is going to be K cap. J cap cross K cap, I cap. K cap cross I cap, J cap. So, if you reverse this, so J cap cross I cap, this is going to be minus K cap. So, I cap cross K cap, I cap cross K cap, minus J cap. So, K cap cross J cap, minus I cap. Just you have to reverse. Now, what is there? I cap cross K cap, leave this minus. I cap cross K cap, where it is there? Here it is there. I cap cross K cap. I cap cross K cap is minus J cap. Already here one minus is there. Therefore, minus into minus. Therefore, plus J cap. Now, what is the direction of force means? On this charge, force is going to be acting in upward direction. Therefore, how this charge is going to move means like this. So, what is the path followed by the charge? Whenever charge is going to be entering perpendicular to the direction of the magnetic field means circular path. So, in this case force is acting in upward direction. Now, see in this case how the force is acting. So, F bar is equal to Q into V bar cross B bar. Now, positive charge plus Q. What is V bar direction in this? Upwards means plus J cap. B bar means minus K cap, that one is not going to be changed. Now see J cap cross K cap, J cap cross K cap, I cap, here already minus is there, minus I cap, therefore force is acting towards left. So towards left, it will be coming like this, isn't it? Now in which direction force is going to act, we are getting by using this rule, I cap cross J cap, cross product of two vectors is going to give the resultant force direction. So, same question they will give, an electron is going to be entering, they will give. Whenever they give an electron, electron is having which charge? negative charge. Therefore, this formula F bar is equal to, remaining all are same, but here you will get minus remaining inside I cap cross minus k cap. So this one we will get minus into minus plus, this minus into minus plus, but I cap cross k cap, I cap cross k cap, I cap cross k cap is minus j cap. Therefore, just quite opposite for this, minus j cap if electron is entering. Then this electron will be moving. Minus j cap means force is going to act downwards like this, clockwise. Previous one, anti-clockwise. So either clockwise or anti-clockwise also, direction also is going to be represented by this force. So this is the best method whenever they are going to get or they are going to ask this question. You should be very thorough with this. Again, these we discussed in our basic classes. Vector product and scalar product will be there in basic 17 videos we have given. So in that, if you observe, you will get this, isn't it? So this is about force direction. Now what is the path followed by this means? Circular path. Okay, circular path. Then what is the radius? What is the required force? How much force is going to act? We will see now. If magnetic field is into the boat, if magnetic field is into the boat, now charge is entering perpendicular to the direction of the magnetic field. So perpendicular to the direction of the magnetic field means like this, positive charge with some velocity. Then path followed by this charge is going to be circular. Therefore, the circular path we are drawing like this. Then what is the radius of the circular path and how much velocity and how much time it is going to take, time period. So many things they are going to ask. We will see all those. Now, what is the force acting on charge? F bar is equal to Q into V bar cross B bar. So F is equal to QVB sin theta. Now, what is the angle between V and B? We said here 90 degrees. Therefore, F is equal to QVB. This is only maximum force. Now, whenever object is moving in circular path, which force is required to move object in circular path means centripetal force. Therefore, this equation should be equal to centripetal force. Again, what is centripetal force equation? In laws of motion lesson we discussed mv square by r equal to qvb. Otherwise, mv square by mr omega square. So centripetal force total you will be having three equations. So mr omega square equal to qvb. Otherwise, mv omega equal to qvb. So out of these three, any equation you can take depending on what they are asking. So if they are asking radius, from this r is equal to, one v will be cancelled. R is equal to mv by bq. So radius of this circular path is going to be mv by bq. So what is the product of mass and velocity in laws of motion? Momentum. Momentum by bq. And what is the relation between kinetic energy and momentum in work energy power? So kinetic energy equal to P square by 2m. Then what is P square? 2m kinetic energy. What is P? Root 2m kinetic energy. Therefore, root 2m kinetic energy by bq. So see how many equations are getting from this equation. So this is the radius of the path followed and in terms of momentum, kinetic energy, velocity. Next, what is the time taken to complete one revolution in this? So in first year classes, so many times we discussed velocity equal to distance by time. What is the distance for one complete path? 2 pi r. What is the time we will call? Time period. Therefore, time period is 2 pi r by v. So 2 pi by v. Now what is the radius we got? So total three equation, any equation you can use, mv by v. Therefore, t is equal to 2 pi m by bq. So time period. Once you got time period, you will get frequency. So what is the frequency means? Reciprocal of time period. So bq by 2 pi m. So if you observe, time period is not depending on velocity, but radius is depending on velocity, mass, magnetic field, charge. So on these equations, now today you can practice on these equations how we are going to get questions. We will see in our next class, but you can try to remember these equations. From here also you will get time period relation. So omega is, we can write 2 pi by t. So in so many ways you are going to get the answer. So you have to recall these formulas to remember. Now in this, two things you got. One is, what is the path followed by the charge? If theta is going to be 0, theta is going to be 180. If theta is 0 or 180, path is going to be straight line. If theta is going to be 90 degrees, path is going to be circular. Since it is moving in circular path, we got these many equations. So remaining we will see in our next class.